Nitish, am I audible?
Master.
Why your friends are late today?
So I'll just text him, sir. 1 second.
Yeah, do it fast.
Good evening, sir.
Sir, Tarun didn't pick up, sir. Sankalp won't come,
Are
sir.
here? Your cameras.
Yes, sir.
Papa is here. Nitish is here. Sankalp, where is Sankalp? Tarun
Sir, Sankalp won't come today, sir.
won't come today. Why?
Yes, sir. I don't know, sir. I think I'm out of.
Okay. You should join every class because even if one concept you leave, na, it will be like taking you back. Okay.
Yes, sir.
More minutes. I'll be waiting and then I'll be starting. Next time, I require that you must join in time, right? Dot in
Okay,
time.
sir.
If it is 5, see, teachers, you should be coming before teachers, na?
Yes,
Sir,
sir.
yes, sir. He's coming, sir.
Okay. So if it is 5, you should join dot in 5. Because we have to complete syllabus, lot much before than your school time, so that you take your time to understand the things, analyze the things, ask doubts, isn't it?
Yes, sir.
And simultaneously, we don't have to run fast also, so that you don't understand. If you waste time, so that will be kind of problem for you now, because it is you who are the learners. You have to learn. You should be keen to learn. 7-8 minutes are wasted. In 7-8 minutes, I can explain you 2-3 concepts. Isn't
Sir,
it?
only Tarun has to join.
Only Tarun has to join. Okay.
Yes, sir. Sankalp won't attend.
Is he ill or what?
No, sir. They went out.
Okay. Okay, let us start.
Sir, the guidelines
Okay.
for writing the units, I didn't understand.
Okay, guidelines you could not write.
Yes, sir.
Okay, I'll explain that at the end. Okay.
Yes, sir.
Just make me
Yes,
remember
sir.
at the end of the class.
Yes,
So
sir.
today we'll be learning 2 things, that is screw gauge and measurement of time. Before screw gauge, I want to tell you measurement of time. Okay, measurement
Yes,
of time. Or before, let us complete screw gauge only, because we were doing the measurement of length now.
Yes, sir.
Let us complete first screw gauge, and then we enter in measurement of time.
Yes, sir. We
So
are doing a
principle of
vernier
screw gauge.
caliper.
Huh?
No, nothing.
Screw gauge. Principle. First you have to do what is the principle.
Of what, sir?
Screw gauge. Screw gauge is a device. Okay. Let me show you.
Similar to
Can you
vernier
spell
caliper.
it, sir?
Screw gauge.
Screw gauge.
Yeah.
This is a screw gauge.
So you didn't share your
Okay.
screen.
Now we place the things whose diameter or length. Generally we measure diameter from here. Are
No, sir.
to be
You didn't
measured.
share your screen.
Okay. Here is not there. My mistake. Sorry. Is it there now?
Yes, sir.
Yes, sir.
Okay. So this is a screw gauge. Okay. With this, we like the thing that has to be measured is to be placed here. Okay, and this
Yes.
can measure very small things also, even the diameter of your hair. Okay, even that it can measure. Understood?
Yes, sir.
I need you to draw this, but
I have to
after
draw
the
this?
class, you have to draw this
Oh.
to the internet. So I'm writing the principle. On which principle does it work? So first I'll be writing, then I'll explain you. The pitch of a screw gauge is the distance moved along its axis
Should we write this?
I'll tell you. See, what is the distance? Like, if I measure something of this diameter, so I have to rotate this shaft. I have to rotate so that it goes closer. Okay, it goes closer. So there will be some axial distance covered.
Yes, sir.
Agree? There will be some axial distance covered. So that
Yes,
distance
sir.
covered in one complete rotation, that is called the pitch. Okay, that is called the pitch. Got it?
Yes, sir.
And that is the pitch. First thing. Second thing, the least count. What is the least count? I told you the definition of least count. Somebody tell me.
The least count is the
Sir, is equal to 1 by n MSD.
Not in terms of your vernier caliper. What is generally the word least count?
Sir, it's the least measurement that can be observed by
Exactly. Very good. Who said that? Who said that?
apparatus.
So you said
Me,
what
Said
sir.
that?
between the MS.
Congo whale.
Congo. That's good. That's good.
So you said it was
Least
difference
distance that
between
any apparatus can
vernier.
measure.
What do you mean by the least count of a spoon rest?
See, you have that 15 centimeter scale with you.
Sir,
Okay. So how what is the least value you can measure with it perfectly?
a millimeter.
Millimeter. That is the least count of that scale.
Yes.
Understood? This is the least count.
Oh, okay. So
I
it can be like 1 millimeter or 1 centimeter. So mostly this is also
First of
1
all, write
millimeter.
this down. See, what is the least count of screw gauge? So screw gauge has least count very much lesser than that of your vernier caliper. It can measure very small distances with respect to vernier calipers. Okay, so when you'll be asking
millimeters.
which, when you get a question something like which one has got the largest least count, so what will you say,
Least-
vernier caliper or screw gauge?
Vernier caliper.
No, it's
Okay,
the screw gauge.
now if you want to
A
take perfect
larger least
measurement,
count.
Not
larger
like that.
least count.
Like the most least count. So the least is the count.
No, larger least count value. Which one has
Oh,
got the larger
then
least count
it's
value?
the vernier caliper.
Vernier caliper has got the larger least count value because it can measure something of millimeters, and this can measure something beyond millimeters, below than that. Okay, below than that it can measure, right? So this is the least count. Okay, now you write the definition of the least count and the principle, and then I'll explain the formula also.
Yes.
Yes, sir. The least count, we already wrote the definition.
We wrote for
Definition
vernier
is-
caliper.
this is for screw gauge. Least count for screw gauge. That was for vernier.
No,
caliper,
sir,
na?
we wrote for least count and least count of vernier caliper. We wrote
You
two
must have written
definitions.
the general term least count, the meaning of term least count. Then you must have written the least count for vernier caliper. Now you write the least count for screw gauge.
Okay, sir. Sir, should we write the least count of a screw gauge or just screw is enough?
Screw gauge. Screw gauge.
You have written
This
screw,
apparatus is
sir.
called screw gauge.
Seven is seven.
Screw gauge I have written here.
Seven
Uncles have joined.
is on in
Hello,
Hello?
hello, sir.
Yeah, perfectly audible.
Sir, sorry, sir. Actually, I'm not in my house. I'm outside, so it took me some time to log in.
Problem. But you should do all these things earlier, na? So
Yes,
next
sir.
time, I need every one of you to be dot in time. If it is 5 o'clock, I need you to be here at dot 5. Not even 1
Sir,
minute delay.
sir, you're taking on next class, right?
Pardon?
You're taking on next class, right?
yes.
Next class is also with me.
Yes,
So,
sir.
so you
I'll
just stay in
Yes,
meeting.
sir.
Give you 5 minutes break. Will that be fine?
Oh,
Yes, sir.
Written everyone this thing?
Yes. Sir.
Yes, sir.
Sankalp, for Sankalp, I'm explaining it again. See Sankalp, am I audible to you?
Yes, sir. Yes, sir.
See, this is a screw gauge. Screw gauge is something which is also used to measure the length. Okay, it is generally used to measure very small length. What happens here? Whatever you want to measure is generally kept here in this between part. Okay, let us say we have to measure this ring, diameter of this ring. Okay, so we'll keep it
Yes,
here,
sir.
and then what we'll do, in order to adjust it, we'll rotate this. We'll rotate this. Okay, we'll rotate this, and it will while rotating, this will come closer to it and get it fixed. So as soon as it touches it, we'll stop rotating. Okay, and then what we'll do, we'll check the measurement. How measurement is done, I'll tell you later. So this is the principle.
Yeah.
The pitch of the screw gauge is distance moved along its axis in one complete revolution. Like if one rotation you give, what distance it has moved axially, that is the pitch. And the least count is what? Least count is I am explaining in the next slide. Everyone?
Yes, sir.
Yes, sir. Understood, sir.
Okay, I am changing to the next slide. So basically, what the formula of the screw gauge earlier in vernier caliper, what was the formula? Sankalp,
So
tell me.
it was M.
1 by n MSD.
1 by N. 1 by N.
1 by n.
Yeah.
It was
Yeah,
N minus 1 by N.
Nitish, I didn't know.
So I thought it
Dev
was
has got
N
changed
minus
to
1
Sankalp.
by N embedded.
That's from Sankalp.
Sir, can
Sir?
you hear me, sir?
Yes,
Ask
sir.
from Sankalp. What is the least count formula for vernier caliper?
Sir?
Sir,
Am I
is
audible?
it N minus 1 by
They
N
wait.
MSD?
Sir is asking Sankal.
Hello?
Exactly.
Sir, can you hear me?
Please wait. I'll answer you. I think Sankalp is not audible.
Is
Nitish,
outside.
what did he
is
say?
outside, is in the roads.
Nitish, what did he say?
Sir, N minus 1 by N MSD, sir. I think that's what he did yesterday.
See, generally, if you have been asked that what is the least count of a vernier caliper, you should say 1 MSD minus 1 VSD.
1 VSD.
Then after that, we go for some simplification in order to gain that x by n value. Understood?
Okay,
So
sir.
you would say
Yes,
the
sir.
In
difference
the same
between
case, the
MSD
least
and
count of screw gauge is pitch of screw divided by total number of divisions.
Oh, so if there is 10 centimeters and the pitch is 1 centimeter, I have to divide 1 by 10.
No, I tell you. Yeah, something like that. Pitch of the screw divided by total number of divisions on the circular scale. Okay. For example, if the screw is moved by what is pitch first? Tell me what is pitch?
The cal wait, I
In
The
order to
rotating
rotate
part, the axis.
when you rotate
the
it for one
distance moved along the
revolution,
axis.
what axial distance it has moved. So if the statement
Yes,
goes
sir.
like, that while rotating one revolution, the axial movement was for 1 millimeter. One revolution was for 1 millimeter, or let us say two revolutions. Two revolutions, it was 1 millimeter. If the screw moves by two revolutions for 1
2
millimeter,
millimeter.
and circular scale has got 50 divisions. 50 divisions.
Millimeter.
Then tell me the least count.
1 by 50, which is wait.
Tell me the least count.
Sir, 25.
Sir,
Is it 25, sir?
No.
sir, how many
25 is the wrong
how many
Sir, which
revolutions
of
again?
these is a pitch, sir?
is that, see here, this was my least count, this was my screw gauge, so I have to rotate this. So like in one rotation, what is the axial distance covered? In one rotation, what is the axial distance covered? That is the pitch. This is what I have defined here.
Sir,
Pitch of the
So
screw
you
gauge
have
is the
given
distance moved.
one revolution is 1 millimeter.
no,
And
sir,
two
of two
revolutions-
Sir,
revolutions is
0.5.
1 millimeter.
Sir, 0.5 millimeters, sir.
No, that is the wrong answer.
Sir, one revolution, right?
2 revolutions, sir. 2 revolution, 1 millimeter.
Question is, in two revolutions, it is 1 millimeter that is recorded. You have to find the least count.
So
Okay,
like
sir.
finding the pitch of this, how do I find the pitch of this?
You search in the Google screw gauge, you'll get it.
What, sir? Oh yeah, I remember. Okay.
You're on mute.
Say, is it 10? I mean, no, wait. Wrong.
Okay, I'm solving it. See here. What is my pitch?
Wait.
Everyone be
Sir.
quiet now. Everyone be quiet. I need 100% silence now. See here. Pitch is number of axially distance covered in one revolution. So in two revolutions, I was
0.1.
covering. Please keep quiet. In two revolutions, I am covering 1 millimeter. So in one revolution, I'll be covering how much?
So,
0.5.
0.5 millimeter. Now,
Yes, sir.
my total number of division on circular scale is how much? 50.
50.
So least count will be what? 0.5 divided by
0.5
50.
divided by 50.
It will be 0.001
0.5
millimeter.
0.01.
Yeah.
Sir,
No,
0.001.
0.01.
0.01. 0.01, sir.
Is it fine with everyone?
Yes, sir.
Got it?
Yes, sir.
Yes, sir.
0.01.
0.
If I give you more such questions, will you be able to solve?
Yes, sir.
Yes, sir.
Okay, that's good. Now we'll be doing the errors.
So
Okay.
circular gives 50. What have you written?
Division.
Divisions.
Has
We have to
to be
divide
divisions.
with total number of division on circular scale.
Yes, sir.
Shall I
So
move on to
yes,
the
Just
next
someone-
page?
So you just have to divide the revolution by the length. You can
Number
get the
of
pitch
divisions on the
and then
circular.
divide
Length
it
by
by the
revolution. Length by
Yeah,
revolution.
that's what I'm saying. Length you can find this. Divide revolution
Ah.
and length.
That way you can remember. You have to divide it by length divided by revolutions, and this to be divided by number of divisions on the circular scale.
Yes. So if it's 3, it will be 3 1 by divided by 3.
Okay, shall we move on to the next page?
0.3. Yes, sir.
Yes, so 1 second. I'll just finish this.
I wrote this.
Yes, sir. Done.
Everyone?
Yes, sir.
Yes, sir.
Now see here. Error. The first thing, zero error. Basically, what we have to do.
Zero errors.
What we have to do first. What we have to do. See, you can see here. There are two scales. You can see here there are two scales. One is there in the circular scale. This is the circular scale,
Yes,
and this
sir.
is the horizontal scale, right? Okay.
Yes, sir.
So what happens there? This is called the baseline. This straight line here, this straight line here is called the baseline. So what happens here? You have to match the baseline. You have to match the baseline with the zero like this. If this is the baseline. You have to, and this is the circular scale. Okay, this is like the circular scale.
Yes, sir.
Okay. So this is 0 point. Let us say this is 1. This is something like below 1.
Or 0.
Okay,
Minus 1 or
something.
0.
Yeah. Not -1 is not there. This is totally circular, so it ends something here.
10 or
So
50.
0 is there. Okay, 0 is there. So you have to initially, when you start taking the reading, now you have to match 0 with this. Okay, you have to match 0. Right?
Oh, like
If
the
this is there,
to the horizontal.
You should
scale.
first equalize it.
Perpendicular to the vertical scale. I mean the horizontal.
Now no error is there.
Yes.
You have to calibrate correctly first.
You have to. This is the straight line, and this is the like division on the circular scale. This is the circular scale. This goes circular like this, and this is straight. So straight line has to be balanced with the zero error. It should
So
be
there is
same
no
in line.
error.
If it is not there, you have to make it 0 like that. Okay. So this is the 0 error. So 0 errors are basically of two kinds. Everyone
Sir?
done? We have to do two things. 0 errors
So
are
what should
basically of two kinds. You have to draw this.
Okay,
Positive
sure.
error. Or wait, let me first complete it if I'm not written. Second one is negative error. Negative 0 error. Positive 0 error.
Yeah, you said there is no positive integers.
here. See here. First
I
see
mean,
here.
no negative features.
I'll tell you. Huh. See here. If the conditions are like this, if zero lies somewhere below, if zero of the circular scale division lies somewhat below, okay, like somewhat behind it, right? So in that case, according to this baseline, this zero is at somewhat negative position.
Yes, sir.
You need to add something so that this zero can be get in the straight line.
Yes, sir.
Okay. So in this case, it is positive error. In this case, it is positive error.
Okay.
You can write it
So
as
it's an error. It's wrong, sir.
this is wrong. This is wrong. This much you have to then add to the initial reading.
If
Okay,
the
this much you have to
final
then
answer
add.
is 10, you have to add 2 to like how much ever you.
No. This is something that is getting added up. Like for example, you have like measured something 5 mm, but did you start from
Subtract
0?
2.
No, na. Huh.
Dave,
Let us say
first
this is
itself
2
you
mm.
should
This is 2
calibrate it
mm.
correctly and then only you should start measuring.
If you accidentally do,
And
that's why I'm saying subtract it.
sometimes what happens, you're not able to calibrate it because the device is also not perfect sometimes. So what you have to do, if error is positive, you have to subtract. If error is negative, you have to add. Are you getting it?
Yes, sir.
In the sense,
For example,
oh, if it's
I
below
tell you.
zero.
See, there is two things. There are two things: error and correction. Error and correction. So if error is positive, that means you have measured something more than its original value. So what you do, you subtract then.
Initial
Isn't
final
it?
value with the calibrated.
If
Or error.
you have measured something more than its original value, so in order to do the correction, you will subtract something now. Are you getting it or not, everyone?
Yes, sir.
Yes, sir. Yes, sir.
So, could you repeat one time?
I'll repeat it. See here. If you measure something, okay, and you get the measurement more than its original value, so in order to do the correction, you will subtract that thing or not?
Yes, sir.
Okay. Similarly, if you measure something less, so you'll add simultaneously.
Yes, sir.
Got it? So if your error is positive, your correction will be what? Negative. If your
Negative.
error is negative, your correction will be what?
Positive.
Positive. Everyone understood this or not?
So,
Yes, sir.
Kongwei, done?
Yes, sir. Yes, sir.
Tarun,
I'm
done?
done.
So give me one.
Tarun, understood?
Finished when?
Understood or not this concept?
so
Yes, sir. Understood, sir.
Okay, Sankalp understood, Nitish understood. Tarun, no answer. Did you understand this or not?
Yes, sir.
Okay, good. Okay.
But
This is
I just
positive error.
wonder,
Similarly,
when do these errors happen?
see, there are many errors are of many types. It can be due to our personal error. It can be systematic error. Okay, there are many kinds of error. Okay, it can be instrumental error. Okay, sometimes what happens, like when you take the temperature, even scale has got some calibration now, and the scale is also made up of some material, and it responds to temperature. So if you measure something at like let us say 20 degrees Celsius, and you say it to be 5 meters, and when you take the measurement at 40 degrees Celsius, the measurement will change because scale has got expanded. Are you getting me?
Yes,
So there are many things. Some things we can control, and sometimes we cannot control the errors. Okay, so we can do the corrections in that case. Got it? You cannot
Yes,
control
sir.
the temperature now. You cannot control the temperature now. So, yeah, you can control if you have some proper instrument, but in general the whole temperature of your surroundings you cannot change. So sometimes we cannot control the errors, so we can do the corrections. Okay, yeah, negative error is when, see here,
when it's
this
below
zero goes up, this zero goes up.
add to the initial value or final answer. So if the answer
we
is
have to-
10, subtract it with 2 or something.
If answer is 10, so you have to add this much value more, na?
Add with 2. Add.
Understood?
Yes, sir.
I don't.
Yes, sir.
Sir.
Like at the starting.
I need to dictate. Write it down. I need to dictate you something.
See, look at this scale.
Yes, sir, I'm done. You should draw the diagram also, right?
Diagram also, unless you don't draw the diagram, you won't be understanding the things.
Yes, sir, done.
Everyone do it.
Done.
Done, everyone?
Yes, sir.
Yes, sir.
Okay. So you write that in the zero error, you write. In the zero error, you write. If the zero mark of the main scale, circular scale, if the zero mark of the circular scale, if the zero mark of the circular scale
Circular state. So is my voice audible?
Yes.
written,
Yes, it is.
Yes, sir.
zero mark of the circular scale coincides with the baseline of main scale. Coincides with the baseline of main scale.
Sir, what have you written
Right.
below that Aron on the right side? You have written Aron gives
Error.
plus.
Error.
Error.
Yeah. Sir, what have you written below that?
Positive correction.
Error.
If the error is positive, you have to subtract. If the error is
The
negative, you have
correction
to
is
add.
negative.
Oh, here.
The
You
right,
have to write, if the
right
error
side
is
corners.
positive, we need to subtract. Correction will be negative. You have to subtract something. If the error is negative, you have to add something.
Coincides with
The baseline of the main scale, coincides with the baseline of main scale. Coincides with the main scale.
main scale.
Written.
Yes, sir.
The screw gauge is said to be free from zero error. The screw gauge is said to be free from zero error.
Sir, sir, am I audible?
Yeah.
Sir, I have a doubt, sir. Sir,
Yeah.
you gave an example where it is like 10, -2, and I didn't understand that.
Okay, I'll tell you. See here. If you have like something, the circular scale zero line is below the baseline. Okay, the circular scale zero line is below the baseline, and you measure something to be 10 millimeters. You're measuring something to be 10 millimeters. So you started the measurement from here now. You started the measurement from here now, isn't it?
Yes, sir.
From 3, let us say this line is 3 line. So you started the measurement from 3 and you measured it to be 10. So it won't be 3 then, it won't be 10 then, it will be 7. Do you understand it?
Yes. Yes, sir.
Did it? So what you did, you got a positive error and you did the correction by subtracting it, negative correction, right?
Yes, we have to.
This is what I
subtract it.
explained there. Do you understand it now?
Yes, sir.
I still don't get it. Tom, you
Written
measured it
everyone,
from
the
the
zero error definition. Zero error definition written everyone.
See, if you start from 2 in a scale and go and your final value gets to 10, if you want to start from 0, you just subtract 10 to 0, you get 8. And the 8 is the correct value.
Okay.
So finish the 0 mark. No error.
Everyone written.
Yes, sir.
Okay. Now you write for positive error definition. Positive zero error right there.
Yes, sir.
If the zero mark on the circular scale, if the zero mark on the circular scale
Yes, sir.
zero mark on the circular scale is below the baseline of main scale. Here you can see it is below the main
So
scale. Right?
positive is above it, sir.
Now see here, it is below.
Positive is below.
Oh, the
Yes.
0 is below.
Yeah.
Oh, I
Then
thought
circular scale it is circular scale is below, main scale is above.
okay.
Okay, so the zero line of the circular scale is below the zero line of the main scale, below the baseline of the main scale. The zero error is said to be positive. The zero error is said to be positive.
Could you repeat if the zero mark on the circular scale is below the
The zero mark on
baseline?
the circular scale is below the baseline of the main scale. The zero error is said to be positive. Zero error is said to be positive.
Yes, sir.
This time just
Written?
change below to above
Yes, sir.
and then it will be negative.
Yeah. Very good. For the next one, you just change it. If the zero line of the circular scale is above the baseline of the main scale, it is said to be
Sir,
negative. Very good, Nitish.
yes.
Everyone write it down.
It's just the opposite of negative zero error.
Everyone.
Yes, sir.
1 second, sir. Done, sir.
Done, sir.
Done.
Yes,
Yes,
sir.
sir, done,
So this
sir.
was all about errors.
So there's only one error.
Two errors. Yeah, zero error only. That is what we have to study here.
Okay,
Negative
sir.
zero error we did. Positive zero. Correction due to error. Correction reading we have done. So there is I have to show you. See what you have to do in order to use this. First, what you have to do, you have to find the least count. What least count? What is the minimum value it can measure? Okay, right?
Yes,
Then we
sir.
have to turn this ratchet. This is the ratchet part. This is the ratchet part. Okay.
Yes.
It is to the work of this ratchet is to advance the screw by turning. Okay.
Yes, sir.
Yes, sir.
Till it gently
Sir, your screen share went away.
Screen
Yes,
share.
sir. Screen share is over.
Fine, sir.
Say that.
You're not audible, sir. Am I audible?
Yes, you are.
yeah, go on. Symbol marking is done on circular scale. or just to mark on circular scale? To mark on circular scale. Sleeve is for the main line. To mark main scale. Just write the words ratchet and thimble and sleeve and spindle and anvil like that, and then you just write it.
Parts of a screw gauge.
Parts of a screw gauge like that. You have to place the object here. First, you have to rotate the ratchet part so that the object gets firmly placed between the anvil and the spindle. Then you have to do what you have to do. You have to read the main scale reading. This is the main scale reading. What reading it shows? Okay, here if it is 0, 1, if this is hiding, like in this case it is 5, and then one more is there, na? So can I say this is 5.1, the main scale reading?
Sure.
Okay, and then you have to note whether how many divisions of the circular scale is coinciding with the main scale, and then circular scale reading will be P into main scale
So it is currently not, it's in tens.
into least
Means
count.
Your voice
Sir,
is lagging.
sir, can you hear me? Sir?
Sankalp, we can hear you.
Oh, so I think. Sir, I can't hear you, sir.
I'm stuck on so your video is stuck. So lag.
Your
So
video
your
is
video
very
is stuck. It's stuck. It's not even moving.
Looking into a
He left.
back.
He didn't leave. He's still in the meeting.
Am I audible?
Yes.
Yes, sir.
So how you have to take the reading? You first, this is the main scale reading. Let us
So
say
you
M
can
is the
share
main
your
scale
screen.
reading.
Sir, I
You
have a
can
doubt,
share your
sir.
screen.
Okay,
Yes,
okay,
sir.
okay, okay. It got stopped because I rejoined, na?
Yes.
I have a doubt, sir.
First, let me explain. Then I'll take take all the doubts. Okay. So what you have to do? This is the main scale division. Okay, main scale division, right? And
Yes, sir.
in the main scale division, you like rotated this thimble, this ratchet, and then the thimble also got rotated. So you have to count the number of divisions on the circular scale that got like acquainted with the main scale division. So let us say that P number of circular scale divisions were there. Okay, above the baseline, and that you have to multiply with least count. Okay, so what is the total reading? So main scale division plus circular scale division into least count. This will be your reading of that particular length that you have measured. So for this, is there any doubt for this particular thing?
No, sir. I think Sankalp.
Understood, everyone?
Yes,
Yes,
sir.
sir.
Now,
Yes,
who
sir.
asked for the doubt?
So, what is the maximum length a spindle can extend to, sir?
Maximum length of
Circular
the spindle.
scale.
Maximum length of the spindle. Exactly, I don't know this. I'll have to check it out.
So if you take a scale and bend it into a circle, that's how much that spindle can take.
Yes, scale and bend it into a circle.
If you do that, this scale and then bend it into a circle, it looks like a spindle. Or the thimble part.
The thimble, not the spindle.
Spindle.
He asked spindle. He asked spindle.
I have a spindle.
So is your video again?
Yes.
The video is stuck.
I can't hear you, sir.
I'm sitting in bikini bottom. I have a chair and all. If from tomorrow you keep on making some decision. Okay?
What?
Audible. Hello.
Konguvel,
Sir, can
are
you
you
get
writing the test? Konguvel, are you writing the test?
writing the test?
Someone asked.
Am I audible?
Yes,
Yes,
sir.
sir.
Sir, why are you even speaking? So your image is not even there.
Yes, sir.
I think
Oh,
some
he
network
joined.
problem is there. The weather is not
He
fine here.
joined.
Oh, now the
The weather is not fine here actually.
So where are you
kind of
attending the
raining.
meeting from?
I am presently in my college,
Oh,
Very cold
my
there.
hostel. Not cold there exactly.
Okay.
Can you see the screen?
no, sir.
you shared it, but we can't see.
Yes, sir.
When
you
your
shared
voice
it.
is lagging, sir.
Yeah,
All
yeah, I know, I
Yeah,
know,
sharing the
I
screen.
know, I know.
The blue screens.
Yes, sir.
Fine now? Can you see the screen now?
You didn't share anything. On.
No, sir.
No, he
So
shared
it's
it,
still a
but you
blue
can't see,
screen.
sir. Yes, sir.
So,
So now you stop your screen share.
Yes.
But you're taking the next class, right?
Yes.
we'll be in this meeting.
I'm taking the next one.
No,
is it fine
we'll
now?
go to
Is it
different
fine now?
meeting. No, sir, we can't see.
Is it fine now?
Can't see. We
No,
can't
sir, it's
see.
still a blue screen.
For me, it's a white screen.
Is you're on a
Is
phone?
it on the
Not
phone?
visible?
No, sir.
Screen not
No,
visible?
sir.
It's not
No,
visible,
sir. Sir, I think you can just speak.
Yes, sir. Freestyle.
I'm just rejoining. Just 1 minute.
Oh, good.
Yes, sir.
Sir,
Hey, we can see
visible,
now.
it's visible.
Yeah, sir, we can see now. Don't leave.
Don't leave.
We'll
Oh,
have a meeting tomorrow from the tab.
Hey, Konguvel, you're writing the
Okay,
test.
yeah.
I'm writing the test, but not in cloud.
I'm writing only
Am I
Friday's test.
audible and visible clearly?
So,
Yes, sir.
Yes, sir.
not clearly, but
Sir, your
Yeah,
screenshot
now
was
it's-
visible when you left.
after you,
But now
now
it's
it's
not
still a
visible.
blue screen.
Oh,
Now
it's,
it came,
we
sir.
can see.
So now it is. Now it is.
Yes, sir. It's visible.
Can you see the screen also? This my
Yes, sir.
sharing screen.
Yes.
Yes,
You have
sir.
written this part? Have written this
Yes,
part?
sir.
Everyone?
Sir. Yes, sir.
Okay.
Yes,
So
sir.
one second.
Okay, okay.
Can you go to the
Write it down first. We need to do one more thing. One more thing we need to do. Measurement of time.
Yes, sir, done, sir.
See, there is like
Okay.
clock is the only instrument you can measure time.
What is M again?
Pardon?
What is M again?
I'm bugging.
Where is M?
Not N. M. M for
Where is M?
mango.
Yeah.
In
Where
the-
is M?
That is M.
Bugging.
Sir, he said
Is it what
something
you're
bad.
talking about?
M.
Sir,
M.
No,
the letter
sir.
M.
Can you go to the previous slide? I'll show you.
Previous slide.
there's,
Okay, which one?
he's probably talking about the millimeter.
No, like the first
Where?
slide.
The before
Even
slides.
Where did you see?
Before the slides.
before,
Where is it?
even before.
First
Even
slides.
before.
The
The
picture
first slide,
slides.
In
sir.
the first slide.
The picture slide.
Yeah.
I'm bugging. Nowhere is there. Okay, see here. Measurement of time you have to see. Fast.
So no, sir. I'm talking about.
Sir, the
Okay,
screw
can you go to
gauge,
the
sir,
first
where the
one?
photo of the
Yeah,
screw
the
gauge was, sir, that page.
Screw
Okay,
gauge.
do that.
Where is I'm bugging?
It's not
So there's
buzzing,
no
sir. It's
M
just
bugging.
M. Sir. It's just M. It's in the screw gauge.
This M.
picture
Not-
gauge, sir.
Not M bugging.
It's
This
just
This M you're talking about.
Yes, sir. The M, the sleeve. M.
This I explained about how to take the measurement of a screw gauge. So what you have to do, you have to measure the length of main scale division after perfectly attaching it. After perfectly attaching the body, in between the anvil and the spindle, you have to measure the length of the main scale. Okay, and simultaneously you have to take the count the number of divisions on the circular scale. Let us say that the number of division on the circular scale is small p, and the length of the main scale is there m. Okay, so in that case, total reading will be m, the main scale division, plus p, the circular scale division, times least count that you have already calculated. This is what I taught. Okay, so let us move on to the measurement of time. Here we have to learn about pendulum.
Okay, sir.
Pendulum.
Oh,
Pendulum, the time period is
Oscillatory
calculated
motion
as
of pendulum.
times. See. Pendulum. First, let me explain what is pendulum. Simple pendulum. I should write here first. Simple pendulum. Simple pendulum. Okay, what is simple pendulum? It is a heavy mass,
suspended by a thin string.
heavy point mass, basically. Heavy point mass known as bob.
Suspended by a string.
Bob suspended from a
Sir.
rigid support.
Sir, these all will come
Yeah.
on the test, which is on Saturday.
Yeah, it will come. This whole chapter
Rigid.
is coming. Rigid support.
That's it, sir.
I'll tell you. By a massless string. See.
So how
Bob,
can something be
simple pendulum.
massless?
I'll tell you. Everything I'll tell you. Your questions are good. Appreciate. See, a simple pendulum is some kind of arrangement with a massless string,
So you could say weightless, sir,
and
but
the bob.
massless.
Massless string and the bob. So there are some kind of assumptions that we make. Okay, in physics, in chemistry, in biology, generally, for solving some difficult questions or some theories. So what we do, we take some kind of assumptions. Okay, assumptions we take, and one of those assumptions is massless string. Basically, we cannot have anything to be massless. Okay, but we assume it to be massless, and what that massless means exactly is that with respect to the mass of the bob, that string has got no mass. For example, the mass of the bob is, let us say, 100 grams, and the string has got 1 gram mass. So it is nearly massless with respect to it. Now,
I don't think
Yes,
the
sir.
string won't even have 1 gram, sir.
understanding it. So with respect to bob, it is massless. That's what we take there.
Okay,
Yes,
sir.
sir.
But so this is there. Okay. So this is one pendulum. Okay, so there are few terms that you have to see. You all know that pendulum goes swinging. Okay, oscillations are there.
So it's like a
It is like
tempo,
this.
sir.
It
So it's also like a tempo. So
Tempo.
tempo is just upside.
Your voice is lagging a lot.
audible.
Yes, sir.
But it's lagging
Sir,
a
it's not
lot.
lagging. No, it's not lagging, sir. Maybe for some people.
Maybe the internet problem. See here, everyone see here, please, because you have to complete it. This is the extreme position of the pendulum. Okay, the last position you are taking it to, and this is the mean position at the center. Oscillations. There are few terms that we have to listen, do. Oscillation. What is oscillation? One
Sir, it's
complete.
one extreme to another extreme.
No, not that. To and fro movement. Bob. Pendulum called oscillation. So see what is oscillation. Not exactly we have to take from one extreme to another extreme. The thing is that you have to take it from the mean position to extreme position. Okay, if you have started the oscillation from a point, so you have to end then and there itself. So I started from mean position, I went to the rightmost position, extreme position, then I went to the leftmost extreme position, then I came back to the mean only. So this is my one oscillation. Are you understanding it?
Yes, sir.
Okay, then we have the term time period. What is time period of oscillation, or just the period of oscillation? The time taken to complete one oscillation. Time taken to complete one oscillation. Understood?
Yes, sir.
It is denoted by capital T, capital T. Then we have a term frequency. Okay,
Yes, sir.
frequency. What is frequency?
Sir, frequency is the number of times it oscillates divide by the time period.
Very good, very good, very good. Number of oscillations per second. Like for example, if you have a friend who speaks too much, so won't you tell him that you are so frequent in speaking?
Yes,
That
sir.
means, so how you are comparing it? You are comparing with respect to yourself. So let us take in 1 hour you speak 5 times and your friend speaks 50 times. So in a particular unit of time, the number of observations for him was more than you.
Yes,
Yes,
sir.
sir.
That is what frequency is. So you specify a unit time. Let us say we specified here 1 second. So in 1 second, how many oscillations does it take? That is the frequency. Got it?
Yes, sir.
The unit of time period is second, and the unit of frequency is second inverse. Second inverse. So first you write this page, then we'll be moving forward. Second inverse. I'll be just
Yes, sir.
completing it with the
Yes, sir.
formula.
Sir, should we stay in the same meeting for the next class or join the other meeting?
Just 5 minutes. No, we have to join with the next like link. Just stay 5 more minutes. I'll be completing it, and then I'll be joining with the next link.
Yes,
Yes,
sir.
sir.
Written, everyone?
Yes, sir.
One
What
second,
will
sir.
take the next? Going to write the formula of
Write the formula for time period. Here, all the definitions are clear.
yes, sir.
Yes, sir.
The 98 full marks in the test from every one of you.
Yes, sir.
Revise everything.
Sir. Actually, I got the permission in the learning, and because Saturday and Sunday I won't be there at Chennai. I will write.
I think you'll have to talk with the administration then.
Yes, sir. I already spoke.
It is done.
Sorry, sir, my net went off. So what's the second one? Oh, oscillation. Okay. Sir, can you hear me? Can
It
you hear me,
says
guys?
error. It says, yeah, I can hear you.
Okay.
It says error receiving video.
Video has an exclamation mark. It's very bad.
Yeah, like hover over the exclamation mark.
Okay, from tomorrow,
I don't have the
can you
negative
create
error.
the meeting there?
Am I audible?
Yes, sir.
Yes, sir.
Nothing.
I'm done, sir.
So I didn't write, sir. You yes, sir.
Write it down fast.
One complete for 2 and 4.
To and fro of the oscillation.
So 1 second, it's almost finished.
Finish.
Done?
So one
Yes, sir.
almost.
Can you take the screenshots?
Okay, sir.
Is
Okay,
there an
sir.
option
Finish,
available
sir.
for screenshots?
Yes, sir. Finish, sir.
Everyone done?
Yes, sir.
sir.
Done?
Yes, sir.
Tarun done?
You can.
So finished.
Okay.
Yes, you can
See,
change.
so like in order to take the observations, what we did, we squared the length, we squared the time period and the length. Okay. So
X
we
and
were
Y
like
axis.
increasing the length and we were gaining the time period, increasing the length of the pendulum. Like this is the length of the pendulum, and we were taking the time period. So it was found that the square of length and the time period, the length, square of time and the length is directly proportional. Right? Square of the time period and length is directly proportional. This was found there.
So
Okay.
if length
This
is
was found there.
10, time square is also 10.
The thing is that proportionality is there. That means the change was constant. Change
Oh,
was
but should
constant.
you
so
draw
if
a
it's
graph
increased
Change
in
was
that
by
constant.
10
road?
means the t square will also increase by 10.
Like if I am changing from T1 square to T2 square, so
In the
the length
in
from
the
L1 to L2, this ratio will always be constant, and that is called the slope. Change in y-axis to change in x-axis, that is called the slope. Change in y-axis to change in x-axis. If you are considering a straight line, so change in y-axis to change in x-axis is called slope. If this is T2, this is T1, this is L1, this is L2. So that is always constant. Okay, the slope is always constant.
Yes, sir.
Everyone understood
Yes,
here
sir.
till here or not?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So this slope is constant
so
and equal to.
I'm saying in the graph you drawn, you written t square in y-axis and length in the x-axis. Shouldn't they be like interchanged?
Yeah, I
Okay,
took t square in the y-axis and length in the x-axis. What is the doubt there?
so you can
So I
change
should.
it however you want.
Pardon?
Nothing, sir.
I'm saying length should be in the y-axis and
It can be wherever you
ta-
want. It's still the same thing.
See, that depends on you. That depends on you. Basically, what we change here and then what we get here, we are changing length. So that's why that is the general convention, and we want the corresponding time values. So that's why we have taken it to be in y-axis.
okay, sir.
Okay. In velocity time graph, we have length here, time here, like that. So every time it is not the same. Now, the thing is that what we are changing, that is generally kept at the x-axis, and what we want as the result generally kept on the y-axis. Okay, generally
Yes,
y
sir.
is written in terms of x. That's why. So that is the basic convention. So what happened? We found this slope to be constant, and that constant was experimentally found. That constant was experimentally found, and that was 4 pi square by g. 4 pi square by g. Okay, what is g here? G is acceleration due to gravity.
Yes.
Acceleration due to
Gravity.
Gravity.
9.8.
Yeah, 9.8. Very good. So if we equate 4 pi square by g with just the time, not the change, just the time, not the change. So with this, so I can write G as 4 pi square divided by
One.
or first we write this. Equate it to be as slope. So
So where did you
G
get
will be
4
that was
4 pi square?
experimentally found. Experimentally found.
Huh?
Experimentally found.
So your
That
voice
was
is breaking,
experimentally
sir.
It was found because scientists said so.
experimentally found. It was found experimentally.
Okay, sir.
Right, everyone.
Yes, sir.
Yes, sir.
Written.
Finish.
Yes, sir.
Shall we move forward?
Yes, sir.
Yes, sir.
Okay. So time period T square by L was given by 4 pi square by G. T square by L was equated with 4 pi square by G. So T square is nothing but 4 pi square by G into L. And T is root under 4 pi square L by G. And that is 2 pi. 4 comes outside, 2 pi square comes outside, that is pi root under L by G. So time period of a simple pendulum is 2 pi root under
Root L by G. T is equal to 2 pi square root L by G.
L by G. This is the relation.
So can you just give us one sum on this?
Sum.
Yes, sir.
Okay, I'll give you. Give you. So what we can infer from here is that it is inversely proportional to root under G, right? And directly
Yes.
proportional to root under length, isn't it?
Yes,
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 sir.
sir.
Okay, like if you are increasing the length, that means it is going to increase. Yes or no?
yes, sir.
Yes,
Sir.
sir.
And if you are increasing the G value, that means the time period is going to decrease, right?
Yes, sir.
Yes, sir.
Yes, sir.
Can you see any mass term here? Any mass term of mass, like what is the weight of the object? If you are taking 10 kg object and 1 kg object, which one is going to have more time period?
I want it from.
So it is independent. You cannot see the mass term here. Now it is independent of mass and extent of swing.
Oh, because the weight is only 1 kg.
Mass is not there, so it is independent of mass. It is not varying with mass. Everyone?
Sir, I didn't understand the 10
Yes,
kg
sir.
and 1 kg example.
You did not understand? You did not understand? Pardon?
Sir, I did not understand the 10 kg and 1 kg example.
Okay, see, I asked like if 10 kg object is there and 1 kg object of Bob is there, so which one will be having more time period? So both will be having same time period if the length is same, because mass term is not there in this time period formula. So if mass
Yes,
is
sir.
not there, so we cannot counter for 10 kg or 1 kg mass. It is same for both. Understood?
Yes, sir.
Okay. So if you have written, you can leave this and you can join with the next link.
Yes, sir.
Okay, quickly join
Okay,
this.
sir.
Written
Thank you,
everyone?
sir.
Thank you, sir. Bye, sir.
Join
meet you
And
again.
with the
Thank you,
next
sir.
link quickly.
So we should rejoin on our next 5 minutes.
Next link, with the next link you join quickly.